1. Let's start just on like the pieces of this that we can look at. So let's look at this section right here first. So I'm raising a power to a power. When I raise a power to a power, what do? Multiply. Okay, and so what is the understood power already on the y? 1. So we do -1 times 1, which is -1. So we get y to the -1. Then we have x to the -1 to the -1. So -1 times -1 is 1. So we get x to the 1. Now we're going to multiply that. Now we have to look at the second half of that. So now we're going to focus on this part. Again, what's the understood power on our x? 1. So when I raise a power to a power, we multiply. So 3 times 1 is what? So we get x to the 3rd. -4 times 3 is, so we get y to the -12. All right. Now for our denominator. What is the only thing in the denominator being raised to the 0 power? X. And so what is that x going to become? 1. Okay, so that becomes a 1. So we don't really need that anymore. So it's all over to y. Because our x to the 0 power becomes 1. And so we just get rid of that x to the 0. And our denominator only has y. Now we can start adding and subtracting. Okay, so now what am I multiplying this y by? That's also, so I'm going to have to multiply it by this one, right? So what do I need to do with -1 and -12? Add them together. What is -1 plus -12? -11. So we have y to the -11. All right, then we're going to do it for x. Is it -11? If it's -1 plus -12, that's -13. All right, for x, what's the exponent going to be on x? 4. And it's all over to y. What's the understood exponent on that y? And so now, when I divide, what do I do with exponents? Subtract. So -13 minus 1 is what? -14. If it's negative, should it be in the numerator or the denominator? Denominator. So we're going to just say 2y to the 14. And do I need to move x to the 4th, or is it good up there? It's good. And that's our answer.
Did you get that?
Yeah, I did.
Yes.
Why do you move the line and the joke to the line?
Because our answer has to have all positive exponents.
Oh, okay.
And so at the end, the last step, if I can move something, I'm going to go ahead and move it. And so once I did this part, there was nothing else I needed to do. So since my answer was negative, we just put it down here,
Wait, so is it -13 minus 1?
which is -14. And so -14 goes to the denominator and becomes +14. All right, for number 2. What all is being raised to the 0 power in the numerator? Just the b. So that becomes a 1. And then in the denominator, what all is being raised to the 0 power? The whole thing, right? So that entire thing just becomes 1. So what we really have here is a to the 4th, b to the 3rd, times 2a to the -2. Okay? So if we're looking at that, I multiply those together. What will my answer be? What do I do with my exponents? Add them. So what is 4 plus -2? 2. So we get a squared b to the 3rd. That's our answer. Number 3. So this is one where we can work our numerator first and then go back and do our denominator. So if I want to multiply these together, okay, I know that 2 is going to stay there. So what will I get for the exponent on my x, though, when I multiply those two terms together? What was that? 2, because we do 4 plus negative 2. What will the exponent on my y be? Because we do 2 plus 2. Because we add those two and we add those two. All right, our denominator, we're raising a power to a power. So I have to take all of these and raise it to a power. When I raise a power to a power, I multiply. So first off, we have to do 2 squared. What is 2 squared? Then we have to say x squared squared. So we do 2 times 2, which is 4. Then we have to do y to the 4th squared. So we multiply 4 and 2 and get y to the what? We just have to multiply them. So 4 times 2 is 8. Now we just simplify that. Can I simplify the 2 over the 4? To what? Now, for the x squared over x to the 4th, okay, when I divide, what do I do with exponents? What is 2 minus 4? Negative 2, so that needs to go numerator or denominator. So we'll do x squared. Then we have y to the 4th divided by y to the 8th. So what is 4 minus 8? Negative 4. And negative 4, so it needs to go numerator or denominator. So we do negative, oops, not negative. So in the denominator is positive 4, and that is our answer. All right, then we have number 4. So for our numerator, we can go ahead and multiply everything. What should the exponent in the numerator be for my x? If I do negative 1 plus negative 3. What is negative 1 plus negative 3? Negative 4. Then for y, what is the understood exponent on this y? 1. And so we do 1 plus negative 1, and what does that give us? 0. So what does that right there become? What is y to the 0? 1. And then our denominator. 2 to the 3rd power is what? 8. But what will my exponent be on my y? 6. All right, now, to write my final answer, can this negative 4 stay in the numerator? You said my desk. Can that stay in the numerator? Where does it need to go? Down to the denominator. So our answer will be 1 over 8x to the 4th, y to the 6th. And that's it. Just like that. Remember, on the test, none of them will be individually as hard as any of these will be. Okay? These are all harder than we will have on our test. We still need to be able to know all of the exponent rules, though. Okay? The exponent rules you need to be sure to know, okay, is that anything to the 0 power is 1. You also need to make sure you know that if you have x squared and you raise that to the power of 3, so you raise a power to a power, that is the same thing as saying 2 times 3, or x to the 6th. If you have x to the 3rd times x to the 4th, you add those exponents, and that's how you get your answer. If you have a dividing one, so x to the 7th over x to the 9th, you do x to the 7 minus 9, which gives you x to the negative 2. And since it's negative, where does it have to go? To the denominator. Okay, if you can remember 0 power, power of a power, adding powers, subtracting powers, and where a negative exponent goes, you will be in good shape. Okay. So that is our exponent rules little section. Okay. That is also the only section of the test that's multiple choice. But that section is multiple choice. Your answers are multiple choice, yeah. All right. So for the next section right here, we just are writing the equations. So, yes, ma'am. Yes, that's fine. So for number 5, to write the equation, okay? So to write our equation, we had to come up with some points first. So I'm just going to go, when x is 0, what is y? 4. When x is 1, what is y? When x is 2, what is y? 1. So in order for me to look at this and write an equation, what is my start value? What's my initial value? What is my A? 4. To go from 4 to 2 and from 2 to 1, what do I need to multiply each of those by? 0.5, which is the same thing as 1/2. So we get B equals 1/2. So to write our equation, we're going to do f of x is equal to A times B to the power of x. Okay. If I ask you some additional questions here, so if I ask you what's your y-intercept, what would you tell me the point is? It's the point 0, comma, what? 4. If I ask you what your asymptote is, what would you tell me? It's the line y equals what? What line can we not cross? The 0. Okay. What if I ask you your domain? What was all of our domains for these? Negative infinity to positive infinity. What about range? What is the asymptote where we can't cross? So it's going to go from 0 up. And I won't expect you to write those things down. I'll have a blank for those if I want them. Okay. Now, for number 6, let's find some points. When x is 0, what's y? When x is 1, what's y? When x is 2, what's y? 20. So what is my initial value? 5. That is also our y-intercept. Okay, it's the 0.05. What is my b? What do I need to multiply by to go from here to here and here to here? 2. So our b is 2. So we can write our function. What would my function be? Perfect. 5 times 2 to the x power. And then asymptote is where? And we have to say y equals 0. And then domain. Negative infinity to positive infinity. And range is going to be from 0 to infinity. All right, so then we'll have to write an equation from a graph. We'll also have to write an equation from the table. It's the same process. Then we have to sketch the graph. In order to sketch the graph, okay, we have to make a table. And we're going to go from -2 to 2. Then we just use our calculator and plug stuff in, okay? So if I take this -2 and I plug it in here, so what is 3 times 1/2 to the power of -2? What is 3 times 1/2 to the power of -2? What was that? All right. 3 times 1/2 to the power of -1. 3 times 1/2 to the power of 0.
3.
3 times 1/2 to the power of 1. What was that? 1.5. 3 times 1/2 to the power of 2. 3/4, which is the same thing as 0.75. Then we just plot those points. -2, 12. -1, 6. 0, 3. 1, 1.5. 2.75, and then we sketch in the curve. What can we not touch? Asymptote. Where is our asymptote? Y equals 0. The x-axis. Is that growth or decay?
Okay.
All right, now we're going to look at number 8. We're going to do the same thing. Make a table. We're going to go from -2 to 2. So 4 times 2 to the -1 is what? Or 4 times 2 to the -2 is what? 1. To the -1. What was that? 2. To the 0 power? Two to the 0 power is 1, times 4 would make it 4. To the first power? To the second power? Perfect. And then we can plot it. So -2, 1. -1, 2. 0, 4. 1, 8. 2, 16. Draw the curve. What can we not touch? Asymptote. All right. And is that growth or decay? All right. Now these, we don't have to graph these. You will not be expected to graph them on a test. In fact, you won't even have a graph. I've already made it so the graph doesn't appear on the test. All we are looking at here is our transformations. So what kind of transformation does that cause to happen? Is the transformation inside or outside here? It's inside our function. So it moves left or right. Since it's -2, it moves it to the right. So it goes right 2. Okay. Because that right there. Now, the outside ones move it up or down. So this would move it which way? Down 1. And then we have one more of these, I think, on the next page. Again, don't have to graph. Which way does that transformation move it? Up 1. Yes. All right. Now we have our word problems. Okay. So just like we have 3 of these, we're going to have 3 of these on the test. We're going to have a growth one, we're going to have a decay one, and we're going to have a compound interest one. Okay. So you have to make sure you know which formula we're going to use. So for number 12, 8 upright dominoes of increasing height are lined up to be knocked down. Already, because it said the word increasing, I know it's going to be a what? Growth. Then it says the dominoes are numbered from 0 to 7. The smallest domino, number 0, is 4 centimeters tall and will be toppled by a person to start the chain reaction. Each subsequent domino is 10% taller than the one before it. What is the height of domino 7? All right, so for this, what is our initial? 4 centimeters. Okay, that right there is our A. That is A. Okay, then we have each subsequent domino is 10% taller. So since it's giving me a percent, I know that percent is a what? Starts with an R. It's a rate, right? Okay. If it gives us a rate, a percent, okay, I have to write that as a what? Decimal. So R would equal what? 0.10. So we need to write our function from that. So we do f of x is equal to our initial times, let's have a quick conversation. If we have a rate, okay, we have two options. It can give us our ratio or it can give us a rate. Okay, if it gives us a rate, we have to use the 1 in there. Okay, we can't just multiply it. In this case, it gives us a rate, and we're looking at growth, so we have to say 1 plus our rate. Okay, we have to do that, otherwise your answer will be entirely wrong. So for this one, we will do 1 plus 0.10 to the power of x. Now, which one, what am I needing to plug in for x for this equation? 7. So we're going to take that 7 and I'm going to plug it in for x. So everywhere I have an x, I'm going to plug that in. So go ahead and do that for me. This test is very formula heavy and very calculator heavy. So what do I get my answer for this? 7 point what? 7 what? 7 what? 7.9? 7.79? Okay. I don't know why I can't hear today. I think y'all are talking very lowly today too. Y'all are very quiet today. And what was the units in this question? So that's our answer. I'm so sorry, dear.
Wait, what if we rounded it up to 7.8?
That's fine too. The only thing that I'm going to be a stickler for, okay, is money. That better be the 2 decimal places. And people. You better not give me half a person, okay? That's the 2 things I'm going to be a stickler for when it comes to rounding. Everything else, I'm not going to care. So for this one, it says a country pledges to reduce its annual CO2 emissions by 5% a year. Already, what does that reduce tell me is happening? Decay. Now, then it follows that up by giving me a rate. What's the rate it gives me? 5%. So because of that right there, we know that R is equal to what? 0.05. Okay, and then it says, if the emissions in 2022 are 2,380. What is that right there? That's our A. That is our A. And it's in metric megatons. Then it says, what is the maximum allowable emissions in the year 2032? So let's write our equation. Our equation. We have f of x is equal to, we take our A, and then we multiply that. What do we multiply that by? 1 minus 0.05 to the x power. Now, for this one, we have from years 2022 to 2032. So what does my x need to be? 10 years. So we're going to take that and we're going to plug that in for our x. So go ahead and do that for me. What's our answer?
1425.
What was that?
425.
1425? Any decimals anywhere? 1424.99. All right, cool. And then what is our units? Metric megatons. And usually it will tell you whatever you need to put next to it right there. After your initial value, it'll tell you if it's whatever your units are. All right. Now, number 14. So number 14 is a what kind of problem? Compound interest. Okay. So what is our principal? That is our principal. That is our P. Now, what is our rate? 3%. So R equals 0. What was that? 0.03. All right. What is our N? Semi-annually tells you N, and so N is 2. Then T is our what? What is T? T is 10. So we have everything we need to plug in. So we're going to get our amount is equal to our principal times 1 plus our rate divided by our N. But our N is 2, so let me fix that. Raised to the power of 2 times 10. And it's money, so it needs how many decimal places? What's our answer? 2,000 what?
137. 45.
Perfect. Is that what you got? Does anyone else get that? Somebody else? What else did y'all get? Let's check that then.
I got 2,129.
2,129 point what? Let me see your calculator.
I put 1587 instead of 1. I did it. Also, I put a 7. I put a 5, 8.
All right. Now, so for this one right here, we have to take and rewrite these radicals as an exponent. Okay? So let's look at the 15. So the root on this one is understood to be 2, and it has an understood power of, now remember, your power goes to the top, like the leaves, and then your roots go to the bottom, like a tree. Okay? So for 16, it's going to be x to the what power? 2/3. For 17, what's our understood root? And then what exponent are both the 6 and the x raised to? So we can actually say 6x to the what power? Then 18, this is just going to be 10x to the what power? Take our power to the top like the leaves, root to the bottom, like that. That's all we gotta do for that. Then the directions are written wrong for 19 through 22. That is supposed to be to write each in radical form. So we're taking it from exponents back to radicals. So the opposite of what we just did. So we write our radical, put the denominator of the fraction as our root, and then we just put 3b to the 7. For 20, yes. I just want to get through all of them. Otherwise, we're not going to make it through all of them. I know. Because these are quicker, that's why I'm going quicker with them. All right, these. What is the root? 2. Then it'll be b to the what power? 3rd power. All right, for 21. What's the root? 5. And then it'll be 3p to what power? All right, for 22, what's the root? And then it'll be 6x to the what power? So that is what we should get for those. Did I slow down on the last 2?
Yeah, I think of the top one.
You need it now?
4 of those ones that have the top one.
All right, so the next section is our sequence section, right? Is that where that starts? Okay, so on the test, the way I wrote the test questions, okay, I'm going to show you. When I wrote the test questions, I wrote them to include the recursive formula, the explicit formula, and a specific term, okay? And so when we do these, even though this direction is not telling us to do all 3 of those things, I'm going to get us to do all of those things because I asked for that on the test. Is that okay with y'all? Perfect. So for number 1, okay, for these, I want us to real quick, we're going to write the recursive formula. So for recursive, we are going to do AN is equal to our ratio times our previous term. So AN minus 1. And then for explicit, we use AN is equal to our initial term times our ratio to the power of n minus 1. That's the formulas we're doing. And how I want these questions answered is we're going to do the recursive. We're going to do the explicit. And we're also going to do the 12th term. This is exactly how I wrote the question on the test. Okay, I put our sequence, then I put this part. So all we have to do is find all of those. So for number 23, what is our initial term? 1. What is our ratio? What was that? -2. So to write recursive, we do AN is equal to our ratio times AN minus 1. That is all I have to do for recursive. Then for explicit, we take AN, we do our initial times our ratio to the power of n minus 1. And which of those two formulas will I use for the 12th term? Explicit. And so then we just plug in A12 is equal to 1 times -2 to the 12 minus 1. And you just throw that in your calculator. What does the calculator give us? -2,048. And so that's how we answer that question on our test. The only other type of question with sequence and series that we'll have on, or for sequences, is, do y'all remember how we had to identify if it was arithmetic or geometric or neither? There'll be a section where you do that, and there'll be 3 of those questions. You'll have one of each. So you just have to know which one it is. For 24, what is our A1? What's our initial? 3. What is our ratio?
3.
And so when we go to find our recursive, we are just going to do AN is equal to our ratio times AN minus 1. Then we do explicit. So for explicit, we're going to take our initial times our ratio to the power of n minus 1. And to find A9, which formula do I use? Explicit. So we do 3 times 3 to the n minus 1. Yes. So your recursive just tells you the next term. Explicit will tell you any term. And so whenever it's us find some random term, we always plug into the explicit. What's our answer? 19,000 and what? 683. Is that what you said? Okay. My ears aren't working today for some reason. All right. We are going to skip that one right there. And we're going to go ahead and do some of these. We are not going to do one like 27. It will not be on the test. Okay. 26, though, will be. Okay. So whenever our bases are the same, all we have to do is take our exponents and set them equal to each other and solve. How do I solve that? Add 3n on both sides. So I got 6 equals, what's 3n plus 3n? Now what? What do I do? Divide by 6. What does n equal? Perfect. That is our answer. Then for 28. It's the same thing, okay? But now, are my bases the same? Is there a way I can rewrite 5 to equal 25? 5 what gives me 25? 5 squared, 5 cubed, 5 to the 4th. 5 to the what gives us 25? 5 squared. Because 5 times 5 is 25, so that is 5 squared. So I will rewrite that, and I will get 5 to the 6th is equal to 5 squared times x plus 1. Then those are the same, so I just get x6 equals 2 times x plus 1. And then you would solve that through to find x. Mm-hmm.
Is 27 not going to be on the test or something?
Correct. All right, and so x, I think, ends up being 2. Is that right? You can have your note card. Any formulas should be included. You're going to need a calculator. Other than that, that is everything that should be on the test.